Let's move forward into our first session here on Fit for 55 policies and investments. And our first presenter here, right, comes from IEA and is Brent Warner, lead power generation analyst for the World Energy Outlook. Brent, good morning to you and welcome to this. Floor is yours.
Thank you, Adrian. Good morning and good morning and good afternoon, or wherever you may be for this, everyone. Welcome, and thank you very much for the invitation to ETIP to be able to speak with you today, to be part of the workshop to help open some of these discussions. I'd be very happy to provide a bit of a long-term and global perspective, touching on some highlights from our recently released Net Zero by 2050, a roadmap for the global energy sector. So our roadmap to net zero emissions by 2050 report that we released in May earlier this year. And I'll try to share my screen here. That should be, maybe Adrian, if you can give me that you can see this.
Yes, we can see it.
Okay, great. Always good to check these days. So I would just be happy to provide them this kind of global view on the kind of transitions that are underway, but also that need to be accelerated. I think it's very clear in the run-up to COP26 in Glasgow very soon now that momentum is building, but it needs to accelerate, and there's an opportunity for the world to address climate change and the challenges there, but that window is closing, and the path to net zero emissions by 2050 is narrow, but as we describe in the report, is narrow but achievable. We still have time. We have many of the pieces of the puzzle, but we need to be accelerating, putting things together very quickly. Now, at the time of publication in this report in May earlier this year, we had net zero pledges that covered from 44 countries and the European Union. At that time, that covered about 70% of global GDP and global energy-related emissions. So it clearly was a sign of the momentum going into COP. We've since had a few more announcements towards net zero pledges. We're seeing those in the recent days, including in more developing economies. And so there is a lot of progress. And I think what we were seeing, though, that was part of a motivation for the report itself, was that the underlying policies and the plans to actually achieve those long-term targets weren't yet in place, weren't really being developed with the kind of detail that we would need. So kind of overarching point of the work is to try and give a feel for the kind of transitions and the speed of the transitions we're talking about in order to achieve these overall goals. Okay, so then that's a bit of the preface, but I will skip through some highlights, but then happy to take questions and the discussion. But I think the first thing to understand is that the International Energy Agency and this net zero scenario, which shorthand here is NZE, is not the only pathway to net zero emissions by 2050, is one of the pathways. And it certainly sits among other scenarios that have previously looked at deep decarbonization, particularly if we look at the IPCC reports and the 1.5 degree report, where we look at the scenarios there that achieved or look to achieve a 50% chance of limiting warming to 2100 to 1.5 degrees. So ultimately, this goal of limiting the global average temperature increase to 1.5 degrees, if we compare against those most aggressive scenarios, to give a bit of a context for where the IEA report sits amongst those, there were only 18 actually of those scenarios that achieve this based within the energy sector alone. So I think that's a very important first point, is that our net zero pathway achieves net zero emissions within the energy sector without relying on offsets elsewhere. And in terms of the technologies and overall levers that we rely on compared to those IPCC scenarios, you'll see a few things to note are relatively low levels, particularly for carbon capture technologies. You see the green bar there at the top left chart here. At the very low end, really, of the carbon capture, the range of scenarios reaching 1.5, also for carbon removal, also using the limited sustainable bioenergy supply. So already those kind of 1, 2, 3 give a sense also of the changing analysis and the changing information we have, but these technologies have not been able to move forward as quickly, that we are also getting clear information about the limitations on sustainable bioenergy. And so we've incorporated those into our pathway directly. I think also to note there is we're sort of in the middle on total final consumption. So consumers what the actual energy services are being provided. Hydrogen is certainly something that's been gaining momentum, as was mentioned by Joachim Baca earlier, is that this is much more prominent in the plans, and so we're at the higher end there. And then also the wind and solar share and generation, we are towards the upper end in terms of where we reach in the long term. So just to kind of give you some context of where we sit and where this scenario is amongst those measures. But ultimately, it's really about the trajectory of the path of emissions and how we achieve it. So the report lays out this pathway to net zero emissions by 2050, looking in depth within each sector and highlighting the key technology and policy milestones along the way. So within the report, you have actually over 400 individual milestones. Of course, far too many to walk through here, but I invite those to look deeper in the report to understand that this is grounded in the energy systems we have, and it's all about the energy systems that we need tomorrow and how do we actually get there? We can't wake up in 2050 and have a net zero emissions energy system. We need to take steps along the way. So those include, for example, on the demand side, we may have things like, you see a milestone in 2025, the first on the top left, of no new sales of fossil fuel boilers. For example, these are the kinds of change that need to lead to a long-term change that need to happen very soon. And if we focus on electricity, you've got the milestones here, or some of the key milestones along the bottom in blue, particularly starting with no new unabated coal in terms of new builds or new approvals from today. So from 2021, the plan, the net zero scenario calls for no new builds there. By 2030, one of the key milestones is scaling up the wind and solar industry significantly. I'll say a bit more about that. And then for advanced economies by 2035, we need to be reaching net zero electricity emissions, net zero emissions from the electricity sector in 2035 in advanced economies. Of course, that includes the European Union. And then net zero emissions from electricity in 2040. Now, the reasons for this kind of ambition within the electricity sector, I think we know well here, the technologies are largely here to accelerate action soon, and that opens up opportunities for electrification to drive reductions in other sectors. And in the end, it's not only about meeting the emissions target in 2050, it's about the total emissions, the cumulative emissions over the period. So in order to stay within the budget to 2050, we need to cut emissions very rapidly by 40% by 2030, for example, on the path to net zero in 2050. We can't wait decades to get there. And that's really a key message of the report overall, is that we need to make the next decade one of action. We need to scale up the wind and solar markets quite dramatically. So 4 times the deployment would be required in 2030 that we had in 2020, which was already a record year and a massive jump from the previous years. So we're talking about close to 400 gigawatts of new wind capacity additions, so wind capacity additions in 2030 of close to 400 gigawatts, far higher than where we are today, almost 4 times where we are today, and the same for solar PV. I'll say more about that. On the electrification front, electric vehicles are one piece of that puzzle, But to give a scale, we're talking about moving electric car sales up to almost 60% of sales in 2030. A massive jump, and in the total number of vehicles also being sold. And of course, we can't forget energy efficiency. This is actually the primary and first fuel from the International Energy Agency's perspective, and something that we need to continually push on energy efficiency opportunities across the energy system. And that means we need to double the pace of energy intensity improvements compared to what's happened over the last decade. So you can see here 3 very clear pillars of energy efficiency, electrification, and renewable energy are at 3 of the core elements of the overall scenario. Of course, if we moving on this path over the next decade, that would also mean clearly we need to invest much more in clean energy. Over the last 5 years, we've averaged about $1.3 trillion globally in clean energy. That's from the end use side, also in renewable energy, and the underlying infrastructure, including grids. By 2030, we need to scale that up, more than tripling where we are today to well over $4 trillion in 2030. Now, it's a massive increase, and this is not just in one country or another. This is in all countries around the world. All regions need to scale up the investment. Those that have started earlier, the European Union, for example, it may not be necessarily tripling, as mentioned, doubling investment in grids, but certainly a scale up across all fronts and in a coordinated way. And we looked into also how that would affect the overall economy, the global economy, and we've done work there with partners externally on the overall impacts on global GDP. So we can see that on top of the expected economic growth,
Brian, you are muted.
Thank you. I'm not sure how I muted Adrian. Hopefully you didn't, just this last part, I hope.
Yeah, exactly.
Yeah.
The GDP part.
Okay, on GDP. So we worked with external partners on an analysis of the economic growth that would result from this investment boost. And it would add alone 0.4% per year to the global growth in GDP, which is the equivalent of adding Japan over the next decade. So a boost in infrastructure investment in the clean energy side would lead to a boost in global GDP and also a boost to employment, which was covered. And that's a very critical part of the overall roadmap, is it's a people-centered transition that we consider the affordability of energy, also the jobs impacts, and there's quite a bit more about that in the report. I think also over the next decade, what I want to highlight is that we often think of the technology and the innovation side as a long-term issue, but I think certainly this group knows well that technology innovation is not, takes time to develop. And so we can't wait to be pushing on innovation that we know we will need. So over the next decade, we need to make efforts in advancing many of the key technologies in electricity, but also beyond, because by the time we get to 2050, in a net zero pathway, almost half of the emission reductions come from technologies that are under development now. They're not yet in the market, they're not yet commercial, and so we need to scale them up, drive down the costs, and so that they are here and ready when we need them in the next decades. Some of those examples, and there are many in the report, but we talked a lot about hydrogen, but hydrogen-based steel, for example, is one key element there. If we're looking within electricity, advanced battery technologies and other storage technologies will be critical to balance the large increases in renewable energy in particular. And then I would just spend a couple minutes here on focusing in on the electricity sector, but I see the time as well, so I'm conscious of that. The electricity element, as I mentioned, needs to reach net zero emissions by 2040, worldwide, 2035, and advanced economy, and that's leading the way to net zero. At the same time, it's meeting a huge increase in electricity demand. So at the world level, we're talking about a tripling of total electricity generation over the next 30 years. Now that's not just in developing economies, this is also in advanced economies with the electrification process going on. So how do we meet that demand? How do we meet that tripling? Well, on the one side, we're going to phase out unabated fossil fuels. We need to phase out and move away from unabated coal very quickly in advanced economies by 2030 and overall by 2040. The role of unabated natural gas also needs to shift. While we see trace amounts for the duration, it's really largely becomes much more focused on flexibility rather than bulk electricity supply. So that leaves an enormous gap there where we have low emission technologies. We have a wide suite of them, including carbon capture technologies. We expect hydrogen-based solutions, so hydrogen and ammonia, to become part of the answer even within the electricity sector. Nuclear power as well. This is a doubling of the global nuclear fleet to 2050, which is a substantial increase and a scale up of where we have been. But you see, we still have an absolutely enormous gap to be met by renewables. So renewable energy filling the gap, going from about 30% of generation in 2020 all the way up to almost 90% in 2050. And as we've seen wind and solar PV come to the market, those costs falling dramatically, are ready to scale up, are ready to drive this decarbonization going forward. So with wind actually being the largest source of generation in the long term in 2050 in the world, very much equal on the same level as solar PV. And these two obviously are variable technologies that then require complete rethinking and changes in the way the electricity systems run. If we're talking about 2/3 of generation coming from wind and solar PV in 2050, and even if we move back, or even in 2030, we're already talking about 40% of generation coming from wind and solar PV. That's a dramatic change. That means we'll already be facing many times in the year where we have 100% of demand met by renewables, and a large portion of that already from variable renewables just in the next decade. And then we will need to keep pushing the frontier of experience, because we only have a couple of countries in the world today that have managed this 40% of generation on an annual basis from wind and solar. And we need to scale this up to much larger regions, to kind of the world regions, and leaders will of course be ahead of that. And that's the kind of key point here. I think I've already made this point clearly, but to give a sense of the scale, we are at the bottom of these mountains. We are starting to climb, but we have a long way to go to reach the total fleet of wind and solar that we need to achieve a net zero emissions electricity sector. I mentioned flexibility, but to highlight that point, and then I'll make the final point on grids, is the key in flexibility is we not only need to have more flexibility in the system, more than tripling over the next few decades, we also need to shift away from unabated fossil fuels, which today provide the bulk of power system flexibility. So here we're showing it in hour-to-hour flexibility, so ramping needs, which of course is only one aspect of flexibility. But to give a feel for how much this changes, in the future, we're going to need much more flexibility from things like demand-side response. We expect battery storage and other storage technologies to play a huge role, so that by 2050, we actually get the bulk of flexibility, even ramping capabilities, from those two sources, demand-side response and batteries, rather than unabated fossil fuels. And that leads to very much this digitalization need and an overall investment in the grids and coordinated planning that was mentioned earlier. And as we're scaling up flexibility, we're scaling up renewables, we need the grids to be ready. That means a huge step up in investment compared to what we've seen recently. So a tripling at the world level by 2030, approaching over $800 billion per year in 2030, and we're below $300 billion in 2020 by our estimates. And then as we decarbonize, so the push to decarbonize fully by 2040 requires that to continue climbing, and then it settles back at a much higher level than what we are used to. the key areas there are, it's largely about meeting growth in electricity demand, the scale of renewables, and of course we have a very large grid system that also needs to be replaced, modernized, and upgraded, which is an opportunity also to digitalize those assets and make sure they're ready for tomorrow's system. So I think with that, I'll close, and thank you very much for the opportunity and look forward to the discussion. Thank you.
And thanks a lot for the presentation here. I think message is clear, right? Electricity, it is the backbone for net zero. There, we just need to make sure that we put the right focus, right, in getting it there. Very interesting charts that we've seen here. There are already a couple of questions here on the chat, but we'll go first in the next presentation with Daniel, and then we can have discussions around the points you made. With that, Daniel, over to you.
Thank you, Adrian. Good morning, everyone. My pleasure to be here today presenting to you also the report that Adrian mentioned before, which was launched recently in June and then jointly by Wind Europe and the ETIPWind. Let me share the screen with you. I hope you can all see my slides.
Is that?
Very good, thanks. So I think I could basically just change the scale of the graphs of Brent and change the title, and we could also apply the same, let's say, growth and so on for Europe. So the trends and the overall messages are very similar to what we have concluded in our report. And because we knew there was a very large number of scenarios out there talking about net zero and how do we decarbonize. We did not want to come up also with a new modeling. Instead, we looked into what the Commission had already done in their impact assessment to meet the 2050 and the 2030 in particular. And so we built our assumptions and our work and conclusions on that as well. I will not get into this. I think it was well explained already. Just to say that power sector will be the first one to decarbonize, and then the big effort will have to be achieved in industry, transport, and the building sector. And so we really need to make a huge effort. But if we look into how the energy sector will look like, what we've got today on the left is a system dominated by oil and gas, and where electricity basically represents around 25% of our final energy uses. This is a system of almost 11,000 terawatt hours. Yeah? Moving to 2050, first of all, was already explained, it will be more efficient. So our system will be smaller, around 7,000 terawatt hours. So that's an important element. Around 30% reductions on final energy demand. But the mega trends here, you can see in this scenario, and the one from the IEA and almost in every other scenario, is that electricity role will almost double in terms of direct electrification. So first of all, so you are always around 55, 57% of electricity uses directly in appliances, yeah? But then the interesting part here also comes on the bottom right left. You will also need a huge amount of electricity to produce the hydrogen and e-fuels that you will need to also decarbonize your industry and heavy, hard to abate transport, like aviation and maritime transport. So it's really all about electrification, whether it's directly or indirectly, but the mega trends are all clear, and I pointed out that in order to decarbonize, the best way or the most economic way to do it is through the use of electricity. I think it's very important to keep in mind so that there is no more debate about the role of electricity overall. That, of course, if we depend more on electricity, it means that our electricity system needs to grow significantly. We are expecting that electricity generation will have to double, more than double from today, around 3,000 terawatt hours to 7,000 terawatt hours in 2050. And I think here the finding as well, this chart looks very similar to what Brent was just showing to us, is that wind under the Commission scenarios will represent 50% of the electricity generated. Complemented with solar will be around 70%. Renewables will make around 85% overall. And the rest is provided by nuclear, a bit of fossil fuel. Perhaps a small difference here is that the Commission does not see any role yet for hydrogen in the power sector. And you think, Brent, you say hydrogen and ammonia could have a role also in power generation. They don't see it in the scenarios, but actually this is a very hot topic for discussions in the different forums. So we will have 50% of the energy, the electricity coming from wind, and we will have electricity representing 3/4 of all the energy needs. So let's look now into wind, first of all, then on the electricity demand, so which sectors are going to decarbonize and electrify, and finally also on the infrastructure to provide all these changes. So on the wind side, what we see to support these numbers of 50% share is there are 5 mega trends on technology. The first one, which was also referred by Joachim at the beginning, it's about the deployment of offshore wind. Yeah? What we are seeing is a multi-gigawatt wind farms, so getting larger and larger, based on larger turbines. Already we see 14 megawatt turbines being sold on the market. We will see soon even larger. Obviously, this is a very complex sector, and so economies of scale, reducing the number of turbines will help you a lot to reduce installation costs. And what we also see is this trend of interconnecting the wind farms across different countries in an offshore grid. That's the first mega trend. The second one is about the industrialization of floating wind. We see here that economies of scale can help us greatly into reducing the cost and to come into more standardized concepts, both for the floaters, but also for the mooring and the anchoring systems. This will help us to also tap into the massive resources of wind, which are at, let's say, a water depths too deep for the traditional bottom fixed technology. And I think 60% of the wind resources are in those areas. So floating will be definitely very, very important to untap those. And the other trend that we see as well is that we start to see projects where hydrogen could be produced offshore, but also off-grid through the use of floating. So that will help us also to produce hydrogen farther away from the coast and reduce the investments in the electrical infrastructure. The third one is about the integration of onshore wind in the environment. This is both in the with humans. So we're talking about reducing impacts for instance, for noise, also optimizing the land use, which is also quite relevant. So here in a wind farm, we can also use the space for farming and for animal growing. We can for crops, sorry. But we are also looking into better ways of turbines to minimizing the impact with animals, for instance, with birds detection systems or for bats. A fourth trend is the repowering of our old assets. In Europe, we have around 200 gigawatts already installed of onshore wind, and many of those have been installed in the late 90s or early 2000s. These are old technology, small turbines, and they are basically using the best wind sites. So repowering those places will help us to basically double the energy output with 1/3 of the turbines and using the latest technology. So that can really help to improve energy yields. And the fourth one is about circularity. Today, turbines are around 85 to 90% recyclable. We need to go to the 100%. Now we need to also look into how other sectors can use the decommissioned materials, both from, say, from the steel, copper, from the tower, the permanent magnets, but also the composites of the blades. We will be looking into technologies which allow us to recycle the blades, which today is still under development. And in the future, we'll also see how turbines use materials which are already recyclable and which can also be coming from recycled turbines to have a full circular turbine. So this is the technology, how we see it together with the experts from ETIP and at Wind Europe. Now the costs. Today, onshore wind is probably among the most competitive technologies for power generation in Europe, but still is expected to decrease costs around 30% in the next 10 years. And this cost decrease is even steeper for offshore wind. Now, it's important so the biggest decrease will be by 2030, and this will be continue until 2050. Yeah. But I think very important element here along this modeling is that this can only work if you develop the expected volumes. If you don't develop the volumes, the cost decrease will not follow these patterns. Yeah. I'll give you an example for floating. Yeah, floating, we will only be able to see these prices in the range of 60-65 euros by 2030. if we develop 7 gigawatts of floating in Europe and a few gigawatts elsewhere in globally. Yeah, that's the only way, because that will help us to ramp up the infrastructure, make the necessary reforms in harbors, so that we can really tap into these cost reduction potentials. And these assumptions are also they're a bit ambitious in terms of the capex reduction, but I would say there is a lot of room for more improvement, or more ambitious, if you wish, in all the parts about the lifetime and the capacity factor, which I think has been quite, say, relatively conservative. So this is on the wind side. If we now look into the demand, and in the report we have looked into the 3 main sectors, which are evenly distributed in both terms of emissions, but also in terms of energy consumption. These are industry, transport, and buildings. Also, we kind of have similar messages to what Brent was saying in terms of electrification of transport. For road transport, we see passenger vehicles being basically based on battery electric vehicles. There were some questions also in the chat about the future of heavy trucks based on batteries or fuel cells. In the report, we present a number of different announcements by manufacturers of trucks. You see already they are putting into the market in a couple of years 500 kilometers range heavy trucks, yeah, with batteries. But you see similar trends also for fuel cells. Then waterborne and aviation will depend much more on e-fuels and hydrogen, so e-kerosene, for instance, and ammonia. And that's will also depend a lot on international policy, the International Maritime Organization, whether they will want to increase ambition, as they have done a few years ago, put CO2 targets. And if they ramp up their ambition, then we will see a huge growth on ammonia vessels, for instance. Now I'm gonna skip building for the sake of time, and industry. I'm gonna give you a bit more of a detail on industry. Industry is an interesting one because it's also the hardest to abate, yeah, the emissions. So what we have done in the report, we've looked into over 50 studies out there. We've looked into the available technologies for electrification, and what we look into all the processes excluding the feedstocks. Yeah? So industry might need feedstock, can be oil, can be coal, can be hydrogen, for instance, for ammonia. And that is excluded. But for all the other energy uses, which is basically power generation, steam, and heat, all type of temperature heats, we've looked into that. And we've looked into available technologies that Brent was also talking about. And what we can see, or we can conclude, is that around 76% of those energy needs can be electrified with technologies which are already mature and available in the market. This obviously changes from sector to sector, and those who are more dependent on very high temperature processes, such as the iron, steel, or cement, will still need to wait for a few years until they have these technologies available. But a lot of technologies which were maybe not in the slides of the IEA, but like mechanical vapor recompression or electric boilers, infrared heaters, or induction furnaces, electric arc furnaces, all that is already ready and is ready to be applicable on the industry. Of course, the question will always depend on what are the prices of that electricity, what are the prices available for the industry to make the switch. But these, I think, are very important findings. And once we develop a set of other technologies like plasma heating or steam cracking and reforming, we could go to almost 100% electrification of industrial processes. So this is on the demand, and then if I go to back to the supply side and infrastructure needs, similar to what has been mentioned this morning, we basically need to double investments on the grids to deliver our scenarios. This is not happening today. We're going to have a session in a couple of hours in this conference on why this is not happening, why you're not investing enough, what is the regulatory framework which could enable this. Joachim has talked us also through this integrated offshore grid development plans and the 10E efforts. Also, the next session, Vasilik is going to be covering with the colleagues the technologies which are needed on these investments. But clearly we have a big gap. And if I take a concrete example of this gap, let's take the North Sea and the Baltic Sea. What you can see here is in the bubbles, in the green bubbles is the operational offshore wind farms, and the yellow ones are the ones planned. For the interconnector, you have the operational ones in blue, in green, those which are under construction, and in orange, those which are planned. And what you basically see here is that there is a huge amount of interconnectors being planned point to point, from one country to another. There is very few of these plans which actually are designed to integrate the wind farms directly into the interconnector. Therefore, we are not just planning any offshore grid. What we are planning is a spaghetti dish of different interconnectors across Europe and different wind farms, which most of them will have to go connected to the shore in a radial configuration. This obviously is posing a lot of challenges in terms of getting the permitting and getting the acceptability. We are struggling more and more to get the landing points. In Belgium, as an example, this is a big headache for the transmission system operator, but also it's happening in the UK. So just to say that we really need to come up with these plans that Joachim was talking about, and we need to do this very, very quick. What we have analyzed in Europe the work of NZE, the ETIPWind, and we concluded that around 1/3 of all the investments are delayed or rescheduled. And only very few of the projects which are being constructed today were well planned and designed in 2010. So it takes you more than 10 years to actually get these projects done. So if we want to have an offshore grid by 2035, let's say, we need to already have a design and a plan today. Now on the investment part, we clearly will have to ramp up our investments. Here you can see from the Commission, this is the baseline, which will only take us to, say, 32% renewables by 2030. If we want to scale it up, go for 40%, go to the 55 scenarios, we need to double investment in the next 10 years. If you look at where the investment needs to go, almost or around half of it has to go to the demand side. And all this is actually excluding transport sector. And around 35–40% need to still stay on the power sector. So the grids, generation, and also for the production of new fuels. So these are huge investments needed to actually get things started. But if you look at it as a share of the GDP, the cost of the energy system will actually not change over time. So today, energy system costs around 10.5% of the GDP, and that will remain the same in 2050. And I think this is super important to keep in mind. Similar to the IEA, the Commission also expects a GDP growth over time. So all those investments that we need to put today actually are delivering huge economic savings. And those are the important ones that we need to tap on. And another element on this discussion about the costs is something that we are excluding most of the time, which are externalities, let's say the environmental costs of the energy technologies. In this analysis, you include the cost of CO2, at least in the power sector and industry, but you are excluding many other costs. For instance, impact on health, land use, water resources. When you do the exercise and you include the costs, the environmental costs, basically you see that on top of your electricity costs, you will need to add another, this is for the power sector now, you will need to add another 50 euros or 60 euros per megawatt hour on external costs, which are not accounted for. And this will reduce, or this is proportional to the share of renewables. So the more renewables, the less the environmental costs. So we should be finding a way to also integrate those costs in our assumptions, and we will conclude that actually making all those investments that we need to do is much better for the economy. So just to close this, maybe on the research, because I think this is a very challenging exercise to try to internalize all different environmental impacts. So on the research part, we say we need to increase investments on the grids, we need to increase investments on renewables, we need to increase investments on electric vehicles, we need to digitalize everything, we need to become smarter. I assume all that needs to also be supported by an increased investments on research and innovation, which is basically the scope also of ETIPWind. But this is not what we see from the current situation. So we are increasing our ambition and our investments, but investments on research and innovation stays quite flat. And I think this is something that we need to revert. I would like to leave it with that. Thanks very much for your attention.
Thank you, Daniel, for all the details here. And indeed, this is very much in line with what Brent has presented before at the global scale from IEA. Numbers more or less the same, right? The idea, again, the same. We are running quite a bit behind the time, but and there are a lot of questions already in the chat box, and I encourage both of you to look at them and try to answer some of them right there. Some of the topics will be reflected in the later on sessions that we have today. But I would like to come to this one that you highlighted at the very end, Daniel. It is the research and innovation part of it. And I think, Brent, you also have an innovation aspect in your points there. No? And if we start with you, Brent, firstly, I mean, you said 50% of the needed solutions are already here, right? And then we still need to look at an additional 45 to 50 with innovation. My question would be, and possibly for both of you, and you can take it from different angles here, is with the existing solutions, how much can we sustain this transition? And with the innovation, when do we need to ramp up that innovation, and what topics do we need to address to complement the existing solutions that we have? So maybe, Brent, you go first.
Sure, thanks, Adrian. And I agree very much, Daniel. I think the line of logic certainly seemed very familiar and complementary, I think, on these points. But I mean, for innovation, I think absolutely, to clarify that over the next decade, I think there's no reason to wait. We have the technologies we need. We need to push fast on deployment, on scaling up wind and solar markets, in electricity, for example. But then we're going to, if we do that at the speed that we've described in the net zero pathway, just beyond 2030, there are going to be some more technical barriers that we'll need to overcome. And we can't wait for innovation, the innovation process, to wait until then. So over the next decade, what we quantified is that the plans in governments for R&D is something like $25 billion per year. That needs to move closer to $90 billion per year over the next decade to then be ready for those emission reductions in the longer term. And I mean, I had some of the examples there on the slide, but hydrogen, advanced battery technologies, in power, we're talking also about ammonia and hydrogen, advanced nuclear technologies for those countries that remain open to those solutions. I mean, on the grid side, certainly advanced digital technologies, we have many of them, but there's still room for improvement there, I think, and also rolling those out to make sure that the systems are ready. And that's kind of the key, is that in order for this to be an orderly transition, we need to be doing things now on all fronts. And innovation is certainly one of those, grid planning is another. And just the last point on innovation I would make is that in the past, we've seen that most of the technologies have been developed kind of in sequence. So you have development, you have the research and development process where the projects are proving a concept, then building on each other. And that leads to timescales of a decade or so for technologies. We need to have more coordinated efforts that are running multiple demonstration projects in parallel to accelerate those timelines. And that's a key aspect of the international cooperation needed in order to meet these global goals.
All right, thank you. Daniel?
Yeah, I wouldn't want to repeat much of what Brent was said, but for me, if you look at, as you give an example, hydrogen, yeah, the main barrier today for renewable hydrogen production, it's available renewable electricity, yeah, and the main barrier to decarbonize the power sector is we are not building enough wind and solar. So I think we need to look at how we apply innovation also on the permitting and on the regulation. So we need to have a regulation which is much more innovative, much more dynamic, which can really accelerate the investments. And if you have a visibility in the market and you know there is movement, there is visibility, then you get a lot of innovation done by the industry as well. So I think that on top of obviously all the technology development, you need to also support at the very stages, particularly at the beginning. I think that part is where we are lagging. Also on the planning, I think planning is becoming super complex. You have an integrated offshore grid. You need to account for so many variables. Now you want to add hydrogen on top. This becomes even more complex. how do you materialize that in a quick way and move forward? And I think we need innovation there as well.
Very good, gentlemen. Once again, thank you very much for your presentation this morning here. As I said, there are, and I put also my questions there in the chat. If you can address them for the audience, that will be greatly appreciated.